All right, Algebra students, this is part 2 for 11.1, measures of center and variation. And here we're going to learn the most important measure of variation, the standard deviation. Super crucial, and it's going to follow you around in statistics, any statistics class you take, forever from here on out. It's like the order of operations of statistics. Okay, standard deviation of a numerical data set, so that means we're dealing with numbers, is a measure of how much a typical value in the data set differs from the mean. Let those words sink in. That means the typical value, any value you just select, how different is that value than the mean? So what is that? Think about that. If you have a data set that's really spread out, are the data values going to be further from the mean or closer to the mean? Further from the mean. If you have a data set that's really, really concentrated just on maybe a couple values, are the data values going to be close or far from the mean? They're going to be pretty close. So standard deviation is going to be an actual measure of how close or how far. The symbol sigma, and that's a sigma, it's a Greek letter, represents the standard deviation. It is read as sigma, and it is given by sigma equals the square root of, whoa, are you scared? Don't be scared. This looks really crazy, but it's not. X1 is the first data value in your data set. X2 is the second data value in your data set. So these are your data values. And this goes all the way to the last value. N is the number of values in your data set. So it's the last value in your data set. And notice what we're doing every time. Since it's a measure of how much a typical value in the data set differs from the mean, differs is difference, we're going to take that data value and we're going to subtract X bar. That's the difference between the data value and the mean. Remember, X bar is the mean. Now on this one, it's the difference between the second data value in the data set and the mean. This one is the last data value in the data set. N just means if there's 12 data values in the data set, this is X sub 12, last data value in the data set, minus the mean. So inside the parentheses, you are doing a collection of how far each data value is from the mean. Then you square each one of them and you add them all together. Okay, then after you do that, you divide by how many data values there are, and then you take the square root. So that looks really, really complicated. We're going to do one example down here, but let's just see if you understand the basic concept of standard deviation. It is not a measure of center, it is a measure of variation, because it's measuring how spread out the data are. It's not trying to be a single number that says, hey, all the data values kind of like this number, like the mean, the median, or the mode. This is a how spread out of the data. So say that you have a randomly selected sample of homeowners in New York City apartment building. We're asked how many dogs they own. Here are the data. 0 dogs, 1, 1, 1, 1, and 2. Okay. A randomly selected sample of homeowners in the suburbs of Yorba Linda were asked how many dogs they own. And here are the data, 0, 1, 1, 2, 3, 5. How do you expect the standard deviations of each data set to compare? What may be the possible cause of the difference? Okay, which one of these is going to have a larger standard deviation? Does the New York apartment building, or is it going to be the suburbs of Yorba Linda? Well, we're looking at how spread out the data are, because the standard deviation is a measure of how spread out these data are. It's a measure of variation. Which data set is more spread out? The suburbs of Yorba Linda. Suburbs have a larger sigma. I never do sigma very well. And I did it up there where it doesn't even make sense. Okay, suburbs have a larger sigma than the apartment building. Why? Why might that be? I'm just going to put a period because this is not. Okay, why might that be? Well, if you're in an apartment building in New York City, what don't you have? You don't have a backyard. And so it's going to be less likely that you have these homeowners in New York owning dogs compared to Yorba Linda, where a lot of them do have backyards. So in suburbs, in the burbs, there's more space. Okay, I hope that makes sense. That's why the data are not as spread out in New York, but more spread out in Yorba Linda. At this point, we're going to try to actually show you how to find the standard deviation, and it's usually a pretty strange number. So we have sigma. Hey, I did a little better that time. Okay, and then you do this, you do the square root. All right. So what I like to do is I like to find the difference between the data value and the mean and just put that into my formula here to find the standard deviation. To do that, I'm going to need x bar, and x bar, of course, is the mean. And so how do we find the mean? We add all these data values together. That's 4 plus 2 is 6, divided by there's 6 data, which is equal to 1. So that's nice. X bar is just 1. So we do the first data value. How far is 0 to 1? Well, that's 0 minus 1 is negative 1. And then we're going to square it. We're going to add. Second data value, 1, right here. 1 minus x bar is 1. That's 0 squared. Well, now wait a second. All of those are going to be 0. So I could just do it a bunch of times. Now you might be going, Mr. Plunkett, do I really have to write these every time? No, but I'm just showing you that we're being really thorough. That's what this ellipsis is here. It's all the data values in between the second data value in the data set and the last. So how many 1s do we have? 4. So this is going to be 0 squared, and then plus 2. That's x sub n. Why is that x sub n? N is how many data values there are in the data set. So 1, 2, 3, 4, 5, 6. So n must be equal to 6. So x sub n is the 6th value in our data set, which is 2. 2 minus 1 is 1 quantity squared. Okay, and then we're going to divide all of that. Woo! I kind of did a line. Divided by n, which we just labeled as 6. Okay, so now it's like really figure this out. Negative 1 quantity squared is 1. That's 0, 0, 0, 0. That's 1. So that's 2 over 6. So what we're going to end up having is the square root of 2 over 6, which is equal to the square root of 1/3. Right? Okay, and the square root of 1/3, what times itself is 1/3? Not really clear. You actually end up getting this really, really gross thing. It's going to be 1 over the square root of 3, which is illegal because we can't have a square root in the denominator. So we're going to rationalize the denominator. Usually you won't have to do this. You could just leave it as a decimal. In the homework, it's going to have you round probably to the nearest 10th or 100th. Okay, anyways, that's going to end up being 3 in the denominator, and there's going to be root 3. So the standard deviation here is square root of 3 over 3, which is approximately, I'm going to get out my trusty calculator here, if I can actually see. As you can see, it's a very beautiful calculator. Okay, let me try to move it down. So, oh, my computer. Notice how fast it is. It actually just went totally blank. Hold on, it's going to work. I apologize for this. This is the joys of working on really, really, really not good material. Okay, I'm going to do it on my phone to try to save you guys the waiting. So, calculator on my phone, square root of 3 is 1.73 divided by 3 is approximately 0.577 or 0.58, let's say. So 0.58. So this is on average about how far the data are from the mean. And if you remember the data sets 0, 1, 1, 1, 1, and 2. So on average, yes, I'd say that's about right. That's about how far away the data are from the mean. Okay, I'm going to end this for part 2 of the video. I'm sorry that that this thing. Oh, now suddenly it's working again because I clicked on Microsoft Word. Anyways, hopefully you see how this works. You're not going to have to calculate this by hand. There are online. There are ways that you can just go on to tools that calculate the standard deviation. All you have to do is type in your data set. That's fine with me. The most important parts are that it's a measure of variation and it's going to be greater if the data are more spread out. All right, I'll catch you up for part 3.